smartness of methods. What are the smart implementations? This is one kind of scams. So generally, if I say like we know only some scam. Scams and what scams is happening. One more interesting scam is Bitcoin scams. So we can say what is Bitcoin? Bitcoin is a ECE.
Good morning all. Sorry for the delay. Due to technical issues, we started the session at 11 a.m. today. Sorry for the inconvenience. I welcome all the participants for the day 8 of Faculty Development Program on Machine Learning in Image Processing Applications. I take the pleasure to welcome today's speaker, Professor Praveen Kumar Bora, sir, IIT Guwahati, to this session. Sir, we welcome you, sir. I take the pleasure to introduce Professor Praveen Kumar Bora, sir. Professor Praveen Kumar Bora, sir, currently working as a professor in Department of Electronics and Electrical Engineering, IIT Guwahati. Sir has published more than 140 papers in various international journals and conferences. Professor Praveen Kumar Bora, sir, guided 15 plus PhD scholars, and sir's research interest areas are computer vision and pattern recognition, statistical signal processing. Sir, we are delighted with your presence today, sir. I like Professor Praveen Kumar Bora, sir, to take over the session. I request Professor Praveen Kumar Bora, sir, to take over the session.
Select Windows screen, allow. No, is my screen visible? Hello?
Sir, your voice is audible, sir. Your screen is not visible, sir.
You enable it again?
We have given you the co-host permissions, sir.
No, but it says your browser is preventing access to your share screen. What I have to do?
We'll sort it out, sir. Within a minute you will get the permissions to share the screen, sir.
Yeah. Oh, okay.
Sir, can you check once, sir? Now we have enabled everything.
Yeah, but still it says that your browser is unable to. Okay, I'll just share screen. Your browser is one participant can share it at a time, multiple participants can share simultaneously. Okay. Browser is preventing. Why it is so happening?
So maybe it's from your end, sir.
Just 1 minute. I'll call somebody.
You can share screen to multiple participants. Choose the option.
Hello?
Only host and only. Host muted.
Browser. Sanjeevok mati diba niki?
Huh?
Browser is preventing it.
মই তেতিয়ালৈ ইয়াক মাতি দিছো এই সঞ্জীৱ দাস সি তালৈ গৈছে গোস্বামী বাপেক ঢুকালে
ঢুকালে নেকি? মাতিছে। One is sharing Zoom, but browser is preventing. How to do this?
So sharing browser is sharing.
I have to.
Browser sharing के लिए अच्छा हाँ. What is going on? The browser is preventing access to the share screen. Oh, so you don't have Teams, sir? Your team?
No, it is Zoom.
Zoom.
But there is some.
Okay. Browser is preventing Zoom. So आपका browser बहुत पुराना है क्या? What is the browser, sir, you are using?
Hello. This is browser in Mozilla. Or maybe
Mozilla.
maybe.
आपके पास वो है सर? आगे कहते हैं.
Yeah, just one minute. Other one is.
Yes, you will go.
Okay, okay.
यहाँ से लॉगिन कर लीजिए सर.
Yeah. Yeah, just 1 minute. I have some problem.
No problem, sir. You go ahead. No problem, sir. No problem. We will wait, sir. No problem.
Yeah.
I think आपको
Oh. Maybe I will.
आप ईमेल लॉगिन कर लीजिए. यहीं से ले लीजिएगा.
Yes. Now it browser problem है नहीं.
वो ब्राउज़र प्रेजेंट कर रहा था मोज़िला की जगह इसको लगा दिया है क्रोम को शायद ये तो नहीं करेगा.
Yeah, now I can go to my mail.
आप मेल करिए वहाँ से लिंक मिल जाएगा आपको ना इसका मीटिंग का.
Yeah.
तो यहाँ पे डाल दीजिए आउट पर आउट कर दीजिए आउट आ जाएगा. आपने यहाँ से कभी लॉगिन नहीं किया है?
नहीं.
ये अग्निगढ़ का लॉगिन कर दीजिए.
Yeah.
I'm right now in Bora's room.
Sir, mouse लगी थी.
Mouse लगी थी. itu very
ऐसा ये आपका प्रवीण आपको जो ओल्ड लॉगिन होगा वो डालिए. ये अग्निगढ़ का है सर. ओल्ड लॉगिन याद करिए जो पुराना था इसको वो डालिए. आउटलुक करनी चाहिए सर.
आउटलुक का नहीं है ना.
हाँ आउटलुक ओल्ड आपका होगा ना जिससे अकाउंट्स वगैरह से जो अकाउंट वगैरह से निकालते हैं आप ना पे स्लिप वगैरह के लिए जो पुराना वाला. हाँ ये हो गया सर. हो गया. आप एक विंडो खोल लीजिए यहाँ पे सर. उसको छोड़ दीजिए यहाँ पे नया खोल लीजिए टेस्ट विंडो. अब यहाँ से आउटलुक प्रिंट आउट करिए. आउट करिए शायद हो जाएगा सर. आउट करिए.
No, mail I'll see.
आउटलुक में थे ना.
Now it is yeah.
उसको खोल दीजिए.
कौन सा नेटवर्क खोले? मतलब आउटलुक.
मतलब करो आ जाएगा.
Yeah.
हाँ लॉगिन करिए. Now you have to log in Outlook.
आउटलुक लॉगिन.
ऑलरेडी वो आ गया. प्रणव आ गया. जो आपका पासवर्ड भी शायद आपका सेव है तो इसलिए लीजिए. हाँ देन लीजिए. अभी लिंक ले लीजिए.
No. Okay.
सर्च कर दीजिए.
This one. This one.
लिंक होगा सर यहाँ पे. हाँ हो गया. ओपन ऊपर. कनेक्ट तो होगा लेकिन वो शेयर नहीं कर रहा था. कुछ ओल्ड ब्राउज़र का होगा. अदरवाइज तो कोई प्रॉब्लम नहीं है. ब्राउज़र अगर ओल्ड होगा तभी वो शेयर नहीं करेगा. अदरवाइज they will stop you, then you will not do it.
This one is.
They'll take moment.
Zoom meeting. Zoom में Chrome ही लेना पड़ेगा.
Chrome ही लेना है.
इसीलिए तो
Chrome में इतना प्रॉब्लम नहीं आता है.
Chrome में सर अपडेटेड रहता है ना. जो उसी का ही
मतलब Zoom Google का है. Chrome भी Google का है.
तो दोनों उसका वो compatible है.
हाँ okay.
I think it's some connectivity आ रहा है. I think थोड़ा सा बाहर का external connection है तो उसका टाइम लगता है.
और ये click open.
हाँ वो तो
हाँ ये
तो ब्राउज़र से कर रहे हैं आप सर. आपके पास तो डाउनलोडेड नहीं है ना. ये कुछ अपडेट करिए बंद कर देगा. हाँ do you have
later this is later.
हाँ हाँ ये Zoom मीटिंग लास्ट मीटिंग है. ये करिए है
लास्ट मीटिंग और
सेम थिंग है.
ओपन Zoom मीटिंग.
वही है सर. आई थिंक इवन मीटिंग करेक्शन तो बाद में कभी थोड़ा सा प्रॉब्लम होता है. आएगा क्योंकि आपके जूम का आपने क्लाउड से डाउनलोड नहीं किया, जैसे टीम्स का करते हैं ना, जूम का भी क्लाइंट होता है, अगर डाउनलोड करेंगे तो वो अलग से हो जाएगा, तो आपका विंडो जो है इसमें टैग नहीं रहेगा, आपके ब्राउज़र से नहीं,
मतलब
अलग, तो वो थोड़ा सा फ्लेक्सिबिलिटी ज्यादा होती है। कनेक्शन की समस्या क्या है? तो ये देखो यहाँ पे सर का है, यहाँ पे जैसे नेटवर्क देखिए, यहाँ क्लिक कीजिए,
लॉगिन
हाँ लॉगिन तो हुआ है, नहीं एक बार आ नहीं रहा है, नेटवर्क नहीं आ रहा है, नहीं है तो नेटवर्क क्लाइंट डाउनलोड करके तो हो ही गई, क्लाइंट डाउनलोड करने से बिना क्लाइंट का भी हो जाता है, हमने तो दोनों किया है। हाँ क्लाइंट करेंगे तो ये डाउनलोड हो गया, इसको भी खोल लीजिए सर, खोल लीजिए, ज़्यादा छोटा ही होता है, लेकिन कहीं थोड़ा सा टाइम लगेगा, इसको फिर ऑफ ही कर लीजिए, इसको ऑफ कर दीजिए, ये नहीं कर रहा, वो छोड़ दीजिए, लेटर कर दीजिए, इसको भी क्लोज कर दीजिए। हाँ अभी जॉइन मीटिंग, लेकिन आपको उसमें मीटिंग का वो डालना पड़ेगा, आपको आईडी डालना पड़ेगा, गो टू द ईमेल, सर ईमेल यहाँ जाइए, यहाँ पे ईमेल में ये यहाँ से आईडी डालिए, हाँ यहाँ पे ये है, नीचे है ये थोड़ा सा नीचे करिए, आईडी है, और नीचे करिए, ना सेम मेल, दिस आईडी हुआ है,
Yeah, Praveen.
दिस जस्ट ये दिस इज आईडी,
This is
ये पासकोड है आईडी का, अच्छा आईडी को तो
this is Praveen at
प्रवीण, हाँ प्रवीण पासपोर्ट है, तो प्रवीण डालिए, हाँ तो ठीक है, इसको यहाँ पे ज्वाइन कर दीजिए।
Hello. Hello. Sir, good morning. Bora sir. Good morning, sir. Hello, sir. Hello. Rita madam. Hello.
Sir, sir. Yes, sir.
Am I audible?
Sir, you are audible, sir.
Okay. I think Bora sir was not there in online. Am I right?
No, he is there, sir, online. He was, his screen sharing option is not happening. There was a problem with his browser. So, sir was checking that. Sir is online only.
Is it any problem now? Okay, okay, madam.
Problem
Okay,
is
please.
with screen sharing, sir.
Okay, madam. Okay. Dear participants, please wait.
No, this is that one.
that one. This is I'll close.
यहाँ से तो क्लोज,
ये तो close, okay.
नहीं सर देखिए यहाँ से अगर हो रहा है,
No, it is not.
it will not allow me.
Hello, good morning. So is my screen visible now?
Yes, sir.
Okay, okay. Well, I'll start then. Sorry for the delay. Thank you for the introduction. I'll speak on digital image forensics from machine learning to deep learning. So this is the plan of the talk. I'll introduce the problem, some historical example, and traditional machine learning based methods, and then deep learning based methods, and current trends conclusion. Okay. So what is image forensics? So because digital images can be manipulated easily without leaving any visual clue of manipulation. That is the problem. Okay. So because of that, image forensics comes. What image forensics do? Just like any forensic operation, it find out whether the image is tampered or not. Development of digital image forensics techniques has become essential to verify the authenticity of images. Two approaches to image forensics. One is based on watermark, that is known as active approach, but we will not discuss about that. We will discuss the passive approach, which is based on visual content itself. Okay. There are 4 important image forging techniques. That is these are very common image forging techniques. So forensic is finding out whether it is forged or not. What are the types of forging? That is image splicing, copy move attack, content removal, image retouching. So these are the major varieties of image forgeries. First one is splicing, which is the most common forging method. What it does is, suppose 2 images are there and they are joined together, where parts from different images are joined to create a composite image. So this is a photograph of a senator. This is an actress. She is addressing something, but now it is made that both are addressing. This type of content is given. He is a senator, so this photograph he used for his election campaign. Okay, so this is one of the example of splicing. Next is copy move attack. So in copy move attack, reason from the same image. Okay. So my screen is visible now. Photographs are visible.
Yes, sir.
Oh, okay. So here there is only 2. Both are there. Shifts are there. Here one additional is just it is copied again. So that way this is copy move attack. Just to fill up, you from the same image you are copying something, that is copy move attack. Then content removal. In this figure, this part is completely removed here, and by seeing this photograph you may not be able to visually tell that there was something there. Okay, content removal. And next is, so we have a 4 type of forgeries. Fourth one is retouching. So this is the original image, Newsweek, actually, and same photograph, Newsweek is like that, and Time photograph is like this. So it is manipulated, it is colored in such a manner that it will give a more gaudy look, because this is he is a criminal, photograph of a criminal. So after manipulation, he is made more criminal look like. Okay, so this type of image retouching is there. And sometimes 2 or more forgery techniques can also be implemented by the forger. For example, applying Gaussian blurring or median filtering on a spliced image so that the traces are not visible by the naked eye. So after forgery, again some operations will be done so that it will be still difficult for the person to identify that the image is manipulated. Okay. A historical example, again, suppose this is one. Actually, though we are discussing about digital image forensics, this forging is as old as photography itself. There are some photographs which are forged long back during the time of Abraham Lincoln itself. Okay. But analog forging is very difficult. You have to do it in dark room. So that way, in old days, forging was difficult. For example, this is one famous example. Here, this is a photograph of Mussolini, that is Italian dictator. And there was a person helping him. This person is removed so that he will be looking more heroic. So this is one example of content removal so that this person will, it will suppose reveal more about this person than this person. Okay, so that way this content is removed in order to emphasize this photograph. Okay, so because we want to they wanted to emphasize the heroics of Benito Mussolini. You know, he was an Italian dictator during Second World War. So this was a manipulated photograph. Okay. Similarly, this one already I have given example. This is also okay. Just 1 minute. Yeah. This is another example. Suppose these are 2 photographs, and these 2 photographs are merged together. This was a Iraq war photo published in Los Angeles Times in 2003. So in the published photo, a British soldier was warning a group of Iraqi civilians to take cover from nearby fire, as seen in the top image figure. So this is okay. But these are 2 photographs actually. From these 2 photographs, it is made a composite so that this content is fire is also there, but in this photograph fire is not there. So that way, this image is a composite of 2 different images taken seconds apart and are presented at the bottom of the figure. These are the original image. From this is composed. Okay. And similarly, this one is suppose the Iranian Revolutionary Guard photo released by. So this is again you see that there are actually more number of missiles here compared to here, just to show that the war is very severe. Additional same missile is copied twice. Okay, so that way this is example of copy move forgery. Here only 3 of the missiles successfully launched. The 4th was copied and pasted in, to hide the missile that failed. So it was to hide the missile that failed, it was copied. Okay. Similarly, during that is oil refinery spill, BP, what is known as BP oil spill in Gulf of Mexico during 2010, Borak, that is original photograph is, this is the 3 persons were there, but here only Barack Obama is shown. So just to emphasize him. So this is another example. Okay. Now there are different methods to approaches to image forensics. One is such technique is okay. This is one example is Splice Buster blind image splicing detector. Okay, originally, suppose when we say image, how to detect the image is manipulated or not. Now, original methods were physics based. Okay, I'll just, okay. Just 1 minute. Okay. So original methods were physics based. What do you mean by physics based? Suppose when image is there, that image content itself may be different because of suppose the photograph may be taken by two different cameras. Okay, so different cameras may be source direction may be different, or the illumination color itself may be different. So classical approaches were that. That means you have to find out what is the source from the photograph. What is the where is the light source from the photograph? You will try to find out. Suppose in two different light sources are there, then it will be a spliced image. Similarly, you can find out the illumination color. So from one part of the image, one color, another part of the image, another color. That is the source color. Okay, if that happens, then we can say that the images are manipulated. But now nowadays methods are based on data only. When we say that machine learning based method, so it does not care about the physics of the problem. It is based on the visual content of the image only. Okay, so for this part, we will discuss one important technique, what is known as the Splice Buster blind image splicing detector. So it represents a pixel-based forensic method. The pixel level relationship changes when splicing is done on the scene content. Suppose when we have a, okay, suppose this is one example of splice. Suppose this number plate is pasted from different images. So originally, suppose this part of the image, the local relationship of the pixels, and this part of the image, the local relationship of the pixel will be varying. So that can be used to detect the splicing forgery. That is exactly what Splice Buster does. What it does, it represents a pixel-based forensic method. So every pixel can be checked. The pixel level relationship changes when splicing is done on the scene content. So how do we extract the feature? The investigator is required to select a W by W bounding box that is suspected to include the force region. For example, the number plate itself in this shown figure. The rest of the image and windows of W by W size is used for training and learning the discriminant features of the model. So from the image, one part is for testing, that is the where you suspect forgery, and the rest of the part is used for training. It will be residual. So how it will be training? Computation of residual through high pass filtering of the original image. Okay, this is some relationship. And then because normally this forgery, traces of forgery, because it will be edited in such a manner, only high pass part, noise part, there only you can find out the traces of forging. So that's why we are finding out the high pass output, and then those quantize those outputs. Okay. After that, we get a co-occurrence matrix, and we get the this type of information. Okay. And from that, what we will do is the normalized histogram of the co-occurrences. You know, co-occurrence matrix. H is extracted from the n training windows, and the mean and variances feature of the vectors are calculated. Mean and variance. Variance means covariance, that is calculated. The feature vector of the test data, test area block H is extracted, and the Mallikarjunarao distance is with respect to the training set mean is calculated. Because you have the training set mu, you have the main training set covariance, and then this is the test area. So in the test area, similarly, you will get those co-occurrence histogram, and then you will find out the Mallikarjunarao distance. Now, normally, if we consider from the same image, this distance will become small. Okay, and if suppose if distance is substantially high, then we can say that the block is forced. Okay, so this is the one of the important technique, what is known as this splice buster. What it is done here, that local statistics is found out and compared with the local statistics of the suspected region. If this and that comparison is done in terms of the Mallikarjunarao distance, and if distance is high, we can decide that the image is that part of the image is spliced. Okay, so this is one of the successful method. Now, normally this forgery detection techniques are for particular type of forgery only. So, but to create a realistic forgery, multiple editing operations are generally performed on image. For example, what you will do, suppose you forge the image, then you will you have pasted the image, then you have to maybe again compress it, and you have to do median filtering. So that way different operations are done. So to create a realistic forgery, multiple editing operations are generally performed on an image. Forensics methods developed for only one editing operation performs badly for well-forced images, because the way we develop forensics, anti-forensics also will develop in the same pace. Therefore, your forensic technique should be such that even some anti-forensic operation is already done on the forged image, then also you can detect the forgery. So as you as the image will go on many editing operations after forging, therefore the forensic method should be able to find this manipulation history. That is the basic idea. Okay, developing separate methods for detecting different operations is time consuming. Therefore, we should need a universal manipulation detection and localization techniques. Method that can perform multiple forensic tasks, that is universal methods, are time and design efficient, robust in performance. Underlying idea, design features that can capture the common artifacts left by different manipulation. Okay, this is the underlying idea. Now, you know, there is one very important technique called steganalytic model. Stegananalysis means whether an image contains some hidden data to find out that there are methods are available. Okay, and same method, similar methods now can be applied for image forensics. Image steganalysis is the study of detecting messages hidden in images using steganography. Okay, both steganography and image manipulation sense the pixel values and the inherent statistics of the original image. That is the point that even steganalysis. Suppose when we put a hidden message, the image statistics will be changing. Similarly, if we do some manipulation on the image, then also pixel values and the inherent statistics of the original image will be changed. A universal forensic method is proposed using universal stegananalytic features. Universal stegananalytic features are extracted without any knowledge of the targeted steganography. So unlike in the stegananalysis method, here universal stegananalytic features are extracted from the tempered image. Now, what are those features? Both these features are both spatial and frequency domain features. Some of the features are spatial rich model, SRM. So this is one important features. What is that, SRM? That is, there are some special type of high-pass filters, and they are designed to reveal the those type of high-pass information like stego content or hidden message, etc. Then local binary pattern, like in other cases, here also LBP is a very important parameter, co-occurrence of DCT coefficients, Markov features, etc. Different features are there. Spatial domain features capture the change in correlation among pixel values due to image manipulation, and frequency domain features are calculated from the block DCT. Okay, they capture interblock and intrablock dependency among the DCT coefficients. Okay, so this is the now we have so many features, and corresponding to each features we have a classifier. We have a classifier, and these classifier decisions are fused. To get the final decision about the manipulation. Okay, so that way a multi-class feature discriminant is used for the base classifiers. So this is the procedure is known as the ensemble classifier. Instead of one classifier, a number of classifiers are used, and from those classifiers, results are fused to make the decision whether the image is manipulated or not. So 6 manipulation operations are considered in this paper. That is Gaussian blurring, gamma correction, because gamma values may be different in different part of the image, lossy JPEG compression, because this splice part is doubly compressed, median filtering, resampling, and splicing. These are the operations which are detected. It is observed that SRM and LBP features give the best performance. Okay, so this is a LBP features, and these are the results against this type of operation manipulations. Okay, it is a very good method. Now, like in other areas, deep learning has also come into image forensic methods. Okay. The first application that was in 2015. This is median filtering detection using CNN. Okay. Now CNN, you know that CNNs are very convolutional neural networks, CNNs. So they are very successful in object detection. So why? Because this convolution operation, along with the nonlinearities, can extract the object information from the image. Okay, and will not go to the details of CNN, but we know that CNNs are very successful in object detection. Then how will apply these CNN techniques, CNN-based techniques or deep learning techniques for manipulation detection? Because what is the problem? Because we are not interested in the image content. Rather, we are interested in noise part or residual error part in the image. So therefore, how to do this? Some additional layers are provided in the CNN framework. Okay, how it is done? The first deep learning based method was developed to detect median filtering in images. Why median filtering? Median filtering is utilized by anti-forensics methods. Why? Removing the statistical traces of blocking artifacts. Normally, if we paste two images together at the boundary, there will be blocking artifacts. To remove that blocking artifact, also blocking artifact is due to double JPEG compression. Those artifacts can be removed by median filtering. And median filtering can also destroy a linear correlation between adjacent pixels for the purpose of hiding the traces of resampling. Okay, so these are the purpose of median filtering. Now, CNN can be used to check whether the image is median filter. For this, what we will do? Added a new layer to the CNN that computes median filter residuals. Median filter residuals means suppose the image will be median filtered, and then residual means after median filter, original image you subtract from the median filtered image, you will get the residual. That residual is passed through the these CNNs. Okay, different layers of CNN. So that way, added a new layer to the CNN that computes median filter residuals. Okay, so if the image is not gone through median filter ring, then this residual will be more. And if the image is already median filtered, then residual will be less. Okay, so that way this is the method. Only thing is the rest of the things are you have to train the CNNs, and but only thing you have added is the this median filter residual layer. This is also residual means high pass. After median filter, what is the error? That part only you are passing. Okay. Now, there is another important paper, what is known as the inversion manipulation detection using constrained CNN. So this one is only thing is technique is here median residual, but here also you are use a high pass filter here at this this is the layer, but this high pass filter is based on what is known as the constrained layer, constrained convolution layer learns a set of prediction error filter by constraining the OHS. Basically, this is a high pass filter. What high pass filter we should use, that also determined by training. Okay, unlike median filter, suppose median filter is fixed here, but here weights are also learned so that we can detect the different manipulation. So that way, this is the universal manipulation detection method by Baer and Stam, and it is based on this constrained convolutional layer. Okay. Proposed to learn different manipulation related features automatically from the training data using a CNN. Proposed constrained convolutional layer to suppressing the image content. You see that any forensic operation, you have to suppress the image content and enhance the low-level residuals. That is done by this high-pass filter operation, which is where weights are learned, because central pixel is given -1 and the rest of the weights are learned in such a manner that their sum is equal to 1. So that 1 minus 1 is 0. That means the entire operation is a high-pass filter operation. Okay. And then there is a localizing image forgery using two-stream RCNN. RCNN means region detection CNN. So propose a two-stream RCNN network for localizing different forgeries, splicing, copy move, content removal. One stream of the network, RGB stream, tries to learn the high-level manipulation features. The second stream, that is the noise stream, tries to learn the low-level manipulation related features. Okay, the output features, maps of both the networks are fused using bilinear pooling technique and is used to, then those features are used to again train a fully connected neural network. Okay, fully connected layer and a softmax layer to get bounding box and class prediction. So this is the method, two-stream method. So it is a faster RCNN network and which is used to detect splicing, copy, move, and content removal. So here, basic idea is that region, you have to detect the region. So that way region, it is a RCNN, it will detect regions, but that way splice regions will be identified and their bounding box will be identified. Okay, so this is another technique which is published in 2018. These are the results. Qualitative result of detecting splicing, copy move, and content removal forgeries. Okay, so these are these results. For example, here this content was originally there, but it is not there here, so it is detected here. So that way, these things can be done. Okay. This is the original image. Here, this is spliced image. This is detected. Okay. Now, another approach is what is that camera model identification. Why camera model identification? Because each camera has its own noise pattern. Okay. So that way, there are different approaches to camera model identification from the image itself. So one such technique is a very popular technique, that is noise print. That was also published in 2016, 17. Yeah. So noise print, what is noise print? A CNN-based camera model fingerprint. Why camera model fingerprint can be used? Because if suppose there is a spliced image, then two parts of the image, original part and spliced part, may be captured by two different cameras. And there are varieties of cameras. So accordingly, the camera sensor characteristics will be different. And there is something called photoreceptor noise, nonlinearity, PRNU, so non-uniform noise. So those noise patterns can be identified. If we can identify, then we can identify the camera, and then as a result, 2 parts we can establish whether spliced or not. Inconsistencies is camera specific traces of an image can help detect different forgeries. Why? Because different cameras will have different characteristics, and if an image is normally grabbed by single camera, therefore camera specific traces should be uniform. But if there is a non-uniformity, that will detect forgery. A residual CNN-based denoising is trained to extract the camera-specific fingerprint using a Siamese network-based training method. Siamese network means that two identical CNNs are used, and from the suppose these networks we will find out the suppose this is the original and manipulated, then this difference we can find out, and that we can classify. Suppose if these 2 images are same, then there will be distance will be smaller. If they are different, distance will be different. Okay, bigger. The main idea is that an image pair from the same location of 2 images captured by the same camera should have identical fingerprint, and any other pair will have non-identical fingerprint. This is the simple logic, and Siamese network can learn that. Suppose if this part and this part is same, because basically Siamese network, as the name implies, it learns distances only between these 2 paths. If distance is small, they are from the identical camera. If distance is large, they are from the different camera. Okay, so that way this noise print is one of the one of the important contribution to image forgery detection. Okay. These are the examples. The forged region will have different camera fingerprints than the authentic region. So this is a forged region. So this is not. Okay, image ground truth is like this, and noise print is like this, and here similarly there, here also like that for different areas, because these are the different manipulated objects, so their noise print will be different. So that can be detected using this method. So this is there is one of our paper also, my student's paper, Siamese convolutional neural network based approach towards universal image forensics. So this is the recently it has come out. So here the existing universal forensics methods need all manipulations to be known a priori and cannot detect manipulation not present in the training stage. The constrained CNN-based Siamese network is used to classify pairs of images either similarly processed or differently processed. Instead of trying to find out different manipulations, what we did is in the same image itself we'll have the patches, and we'll find out whether the patches are similarly processed or differently processed. If some spliced object is there, then that part will be differently processed. So that way, the constrained CNN based Siamese network is used to classify pairs of images either similarly processed or differently processed. The constrained CNN learns features that help discriminate similarly SP and DP pairs without learning the class specific features. We do not bother whether it is median filtering, or it is Dept compression, or what type of operation, but we will see whether entire image is similarly processed or some part is differently processed. Okay, presence of more than one type of manipulation in an image is used as a cue of forgery. Okay, this is the example. Given a test image, it is first divided into a number of overlapping patches, and one block is randomly selected as a reference block. Other blocks are compared with reference blocks using the trained Siamese network, producing a prediction for each pair. In case of forged images, the reference patch comes from forged image area. All the forged patches will have high prediction value. If the prediction value is less than a threshold, then the patch is authentic, otherwise it is forced. Okay, so that way, this is one example we have shown. So based that is this Siamese type of network can be used to determine whether parts of the image are similarly processed or differently processed. That is the basic idea. So these are some results. Now, what is the current trend? So basically, therefore, in a nutshell, what we can say, suppose we have to apply machine learning techniques to ascertain whether the image is forced or not. Okay, so for that, what are the methods available? Classically, traditionally, these are classical machine learning based method. So you determine, first you determine the features, just like I said that high pass filter features, basically, they may be using what is known as the specially rich model, SRM filter output, okay, LBP pattern, etc. Those type of features are used, and then a classifier is used to find out whether the image is manipulated or not. Then deep learning based methods are there, because deep learning is very popular for object recognition. Here also we want to apply. How we can apply? Basically, image forensics work on high pass output. Okay. So therefore, because this whatever traces are there, they are high pass information only. So that way we had median filter detector, where one residual of median filter is added at the as a front end to the traditional CNN. Then Siamese network based methods are there. Constraint instead of median filtering, we can use constraint high pass filter, content constraint high pass filter, where filter coefficients are learned by training. That can be also used to detect the traces. Like that, there are different deep learning based process is also there. Now, deep learning based methods are vulnerable to adversarial examples. Okay, so that is the biggest problem in deep learning. So that means if you give one adversarial example, the entire training will be failing. Okay, so this is not only problem particular to image video forensics, it is problem for any object detection also. So this is one of the issues now people are trying to address. It has opened up new research directions for anti-forensics and counter anti-forensics, and consequently developing more robust forensics methods. Okay, the advent of now one more development is what is known as the GAN, generative adversarial network. Has now here you can generate a fake image, means very perfectly. Suppose you have an original image and a fake image, you will be unable to differentiate. Okay, so the advent of this GAN has revolutionized fake image video generation, and GAN-based editing operations are also in use. So you can use GAN to edit your forged image. Then tracing those forgeries will be difficult. This has made GAN forensics a topic of interest for the image forensics community. So these are two of the current trends. Let us conclude the lecture. So classical forensics methods rely on handcrafted discriminant features to detect and localize manipulation. That is machine learning. Machine learning. So, but their features are to be detected, where from you can get the features, either physics from the physics based or from the image processing. Suppose you want to detect some image processing operation, then some high-pass filtering type of operations, and then those type of co-occurrence matrix, local co-occurrence matrix, histogram. So many features are extracted. So classical methods are based on these, those features. Now, deep learning-based methods have reduced the need of feature engineering, and they are trained end-to-end, because you have this image and then training image, and you can train end-to-end to find out the forgery, okay, or find out whether it is forged and localize the forgery, and have achieved remarkable results in various forensics tasks, maybe around 99%, in some cases 98%, this type of accuracies have been achieved. Achieving robustness in performance across multiple manipulations and for combinations of different manipulations is still an open challenge. What does it mean? Suppose whatever traditional methods are there, methods are for either splicing detection or copy mode detection, like that. But suppose same image will undergo JPEG compression, resampling, median filtering, splicing. All these operations are to be set by a simple technique, by a single technique. That is a challenging task. That is known as the universal forensics. Achieving robustness in performances across multiple manipulations and for combinations of different manipulations is still an open challenge. Okay. Adversarial examples, as in the case of any deep learning problem, adversarial examples is a problem in forensics also. And GAN has started new frontiers of research in digital image forensics. Okay. So that's all about this presentation. Thank you. These are some of the references. It is a very classical area because first research started in 90s. So that way there is a person called Potti. He was the first person to do this type of forensic studies. But since then, a lot of works have been done, and these are some of the references. Okay, any questions?
All the participants have unmute yourself and ask the questions. Also, you can post your files in the chat box. I'm just answering the participants can unmute themselves and
Hello?
Sir, Hello.
Hello, yeah. So any questions?
Sir, till now I do not get any queries, sir.
Okay, okay. Then I'll leave.
Thank you so much, sir, for your wonderful session, sir.
Okay, okay.
Thank you so much, sir. You have spared such valuable time for us. Even in the
Okay.
space for teaching responses, sir. Thank you so much. You can see in the chat
Okay,
box,
then.
many topics, and looking at the session is excellent, sir.
Okay. Your audio is not very much proper. I am not hearing much.
I thank once again, sir, for
Okay, then.
I request all the participants to fill the feedback form, which is posted in the chat box. I repeat once again, please fill the feedback form that is posted in the chat box. Thank you all.
Okay, then. Bye.
Thank you, sir.
Okay, yeah.
I am sharing image. No, the browser is printing access to the share screen. Oh, so you don't have Teams, sir? The Teams
No, it is Zoom.
Zoom.